The last phase we want to consider is solids. So I've got this on the overhead here, and this is from the notes that you can get on Moodle. Solids normally can be characterized by crystals, and we call them a crystal lattice. These has a definite shape and pattern to it, so you can actually determine different crystals by their crystal lattice. Again, kind of an intensive property. A lattice is simply a regular repeating form of atoms and molecules in a crystal, and all true solids have crystalline nature. The shape of the crystal depends on the size of the particles in the crystal and the forces that put that crystal together. We also know that crystals in general, solids in general, have very high melting points. I mean, to melt salt, you're going to have to raise the temperature up to several hundred degrees because it's a solid. Or you can imagine melting wood. Wood doesn't really melt, it burns, but it takes a very high temperature. Metals, 600 plus degrees to melt. Okay? And then boiling would be even higher than that. How do these crystals form? Well, they form by evaporation. And we've talked about evaporation versus boiling. Evaporation means that a liquid is turning to gas at the surface of a substance. So that's different than boiling, because boiling requires a higher temperature, whereas evaporation, just like perspiration, we can perspire at different temperatures outdoors. It can be even cold out if you have warm clothes. So evaporation can happen even at room temperature, whereas you wouldn't see boiling at room temperature. The next thing we want to look at is water of hydration. What happens is when a solid forms a crystal, okay, and they go at different rates, okay? Some crystals contain water mechanically enclosed in it because it might evaporate off quicker. So the water actually gets caught in there. There's different amounts of water in a crystal. So for instance, if we look down here, we can see an example of copper sulfate with 5 waters attached to it. Where'd that water come from? Well, it came from when it was making the crystal of that. Sometimes you'll see just the copper sulfate. It's a blue crystal, and the water's not there. We call that anhydrous. The an means not, so not water. But if you have the water mechanically trapped in there, which is a physical change, we call that the water of hydration. We call it hydrated. Okay? Now, there's a special property of crystals. Some crystals, because they trap the water, can actually get rid of the water spontaneously. Like here in the lab earlier this year, we took copper sulfate that was bound to water, and I heated it and the water left and it turned white. It was a blue crystal. Then we added the water back, it turned blue again. See, I had to add the heat to get it to do that. But something like washing soda with this formula has 10 waters mechanically attached to it. All by itself, that water will leave. So this water will leave and eventually it can be totally gone. That is called efflorescence. Efflorescence is the spontaneous loss of water. So you can consider here the vapor pressure of this substance is actually pretty high because it automatically is going to get rid of its water. The water goes from the liquid or solid even to the gas stage. It gets rid of it. So you could bring vapor pressure into this. And then the last thing we look at, all these big words, sorry, hygroscopic. Hygroscopic is the opposite of this. Instead of water being bound to a compound, okay, water is absorbed from the air to a compound. We call them hygroscopic substances. And then there are certain substances that are so hygroscopic, they actually will dissolve themselves. Magnesium chloride, calcium chloride are good examples. I have zinc chloride here, and I'll bring it closer to the camera in just a second. It is called deliquescence. The water from the atmosphere is actually absorbed into the crystals and forms, it dissolves it. It actually dissolves the substance. Diapers use this theory. So let me get a little closer so you can see this. I don't know if you can see the liquid in there. There's crystals. This was only opened one time.